Hey guys, and welcome back to this class, Data Science, Deep Learning in Python, Part 1. I want to use this lecture to mention that all the code for this class is available at github.com/lazyprogrammer/machine_learning_examples. You want to go to the folder ANN class. Okay, now if you ever get stuck when you're coding along or if you make a mistake, check out the code from GitHub to make sure you're doing it right. I update the course from time to time, so you always want to check back for updates. If you check out the repo using Git, you can just do a git pull. In the first section of this course, when we talk about how to make predictions from a neural network, we'll be using forwardprop.py. That's this file. In the next section of the course, when we talk about how to train a neural network, we'll be using backprop.py. That's this file. In the section after that, we'll be looking at xordonut.py. You should recognize these problems from the logistic regression class, but just in case you don't, I've included a review. In the TensorFlow section, we'll be looking at tfexample.py. Now I want to stress that it's very important you try to write code yourself. You're not going to get good at this just by watching videos on your computer screen. So try yourself first, and if you can't get it, go to GitHub for help. Hey guys, and welcome back to this class, Data Science, Deep Learning in Python, Part 1. In this lecture, I'm going to show you how to do softmax in code. So the first thing you want to do is import NumPy. And let's just pretend this is the output of a neural network, or the activation at the last layer. So we're going to say a equals np.random.randan. Say 5 units. Right, so we have 5 different numbers that represent the activation at 5 different nodes at the output layer. And now we want to do softmax on these numbers. So remember that the first step is we want to exponentiate these. So let's do that. Remember, all NumPy functions are element by element, so we get everything exponentiated. Now we would like to divide by the sum of expa. So the answer is equal to expa divided by expa.sum. Okay, so this is the result of the softmax. You can confirm that these are probabilities, they add up to 1. Okay, so the sum is 1. Now, as you know, we're going to be working with multiple samples at the same time. So we're not just going to have one array of 5 elements. We're going to have maybe 100 by 5 elements. So let's try this again with a matrix. So we have a 100 by 5 array. So this would be 100 samples and 5 classes. Okay, and there are some values that are negative, some values that are positive. Now we exponentiate these so that they're all positive. Okay? And then the next step is to divide by the sum. Now you're going to have a problem because you don't want to divide by the whole sum, because then the whole thing is going to sum to 1. And we don't want that. We want every row to sum to 1 for each sample. So perhaps you think we could do something like this, where we sum on axis equals 1, right? Because we want to sum along the rows. So this is going to fail. It's going to say the array can't be broadcasted. That's because you're trying to divide a 2D array by a 1D array. So what you have to do is you have to use the keyword argument keepdims and set that to true. Okay, and now we have an answer that doesn't break. And you can check that the sum along the rows is equal to 1. You might also want to check what that denominator gives you. So if you just did that part by itself, keepdims equals true, you see that it returns the sum and then it's in a 2-dimensional array. So check the shape. It's 100 by 1 instead of just 100.